Hello and welcome to R&D Mathematics. Today we are going to start quadratic functions. Quadratic functions. Now, quadratic function is a function of this form: f of x equal ax squared plus bx plus c, and where a is not 0. Because if a is 0, the quadratic term will vanish. It's a linear function then. So quadratic functions are of this form. For example, 3x squared. So f of x equal 3x squared plus 7x minus 8. That is a quadratic function. Or g of x equal 4x squared minus 1. Still a quadratic equation. Here a is 4, b is 0, and c is -1. So like that, the highest power should be 2. Now, if it appears in this form, we call it the general form. General form. And there is another way which is known as standard form. And that form is f of x equal a times x minus h squared plus k. Now today we are going to actually deal with this form, and then later we'll talk about general form. Now, there are a few things before that I need to tell you. In graph of any quadratic function, I think I told you this before, graph of any quadratic function is a parabola. So any quadratic function, you start with x squared, and using some transformation, you can either have upward parabola or downward parabola, like this or like that, whatever. We can do that. And actually you have seen some of those transformation techniques when we learned about basic functions of graphs. Now, so the standard form, let me take the standard form again. Standard form, which is f of x equal a times x minus h squared plus k. Now, there are a few things to note. First thing, if a is positive, parabola opens up. If a is negative, the parabola opens down. That means like this and like this. Well, you can understand why. The basic, the base function is x squared. F of x equal x squared. Now in this case, a is 1, b is 0, and c is 0, right? So a is positive, and it's like this. And if the base function, if you add a negative sign in front of our base function, we get negative x squared, and it flips around x-axis. So starting from there, those are the two shapes that we are going to get. And then in a quadratic function, let's say it's look like this. This point right here, we call it vertex. And the speciality of the standard form is this, you'll see in a minute or two. This point actually has coordinates h comma k. So see, here h, here k, those two numbers will appear. That's one reason why the standard form is so important. For example, if you had f of x equal, let's say 5 times x minus 3 plus 8, in that case, can you pause the video and think about the vertex? Normally we use letter V for vertex. Vertex is, see, h comma k, even though we have minus here, see here minus h, but we only have h, so 3 comma 8. And on the other hand, you know what, let me give you some examples. Let's write down a few examples. How about f of x equal x plus 8 squared minus 16 g of x equal 3 times x minus 7 plus 42. H of x equal 4 times x, no, negative 4 times x plus 1 squared plus 2. How about that? So vertex f, g and h, can you find the vertex? See, sometimes tables are helpful. So vertex v, vertex. For f, it must be in this form, x minus h form, but in here you have x plus 8. So you can rewrite x plus 8 as x minus minus 8. Now your h is minus 8, so minus 8, comma, k is negative 16. And for g, h is 7 and k is 42. And for h, again the same story as first one, but it opens, opens. Let's add another column. So first one, f opens upward. Second one, again open upward, because here the number is positive, number is positive. The last one opens downward. And next minus minus 1, so minus 1, 2. Okay, I think that is clear. And another thing to note, this line, we call it axis of symmetry. And I may have you to recall some, let me recall you. Now, intermediate algebra basic stuff, x equal 5. If you had this equation, what does it represent? And y equals 8. What are those two things? X equal 5 is always a vertical line going through 5, because x value is 5. No matter what point you check, this line, vertical line, has x equal 4, right? And y equals 8, something like this. Okay, with that knowledge, in quadratic functions, yes, here the vertex is h comma k, which means this point right here, that distance is h, or this point right here is h comma 0, and that's all we need, because for this axis of symmetry story, that's all we need. This line, equation of this line is x equal h. Now again, standard form is actually really useful to tell many things about quadratic function. For example, here k, vertex is h comma k, and axis of symmetry is x equal h. So simply you have it's coming from this part. You just have to make it x equal and write it down. For example, if you had, let's go to the previous examples that we had. And this one, f, g, and h. Now, if I erase this little bit and add one more column here in our, let me add columns here in the left side. Normally we don't do that. Axis of symmetry. So f, again the same story, x minus 8. So because of that, x equal minus 8 is the axis of symmetry. For g, it's x equals 7, and say x must be equal to this number right here. So x equal negative 1. So this tells us, let me erase this. This standard form actually gives us a lot of information. Now, for example, first one, let me draw first one. If the function is given in this form, or if you can convert, believe me, you can convert any given quadratic function into this form. We will learn that later. But if it is given in this form, it's really easy to draw it, because you already know. Now let's actually draw it. You already know the vertex happened to be negative 8 comma negative 16. So negative 8, let's say somewhere here negative 8 and somewhere down here negative 16. So the point is negative 8 comma negative 16. We have vertex and it opens up like this. So you just have to complete it, and then what you need to do, well, because of the shape, because it is in the fourth quadrant and opens up, it's going to hit our x-axis two places. And how are you going to find that? Well, we'll talk about these things in a minute, or in my next video. So the point is, this standard form is really helpful. Roughly, you can, at this point, roughly you can draw it like this. And let's do it G. So this is F. For G, let me use green color. 7 and 40. So far away here and somewhere here. Let me see somewhere here. 7 comma 42. And it will go like this. And it will never hit x-axis. So this function, if I make it into a quadratic equation, like for example, if I make it equal to 0, that's not going to have solutions because it does not hit my x-axis. And then last one, so this is G, H is going to be, let me use blue color, negative 1 comma 2, so negative 1 comma 2 somewhere here, and opens downward, and it will hit my x-axis. So roughly speaking, like that. So that's the start. That's going to be the starting point for my next video. In our next video, we are actually going to uh, I'm going to give you steps how to draw graphs of quadratic function using standard form. Okay, guys, thank you.